good morning friends, and in this video we are going to solve some more different forms of the integrations. And now our focus here in this video will be on trigonometrical forms. So now I take one example, and then since I'm solving all this, so I just take different forms. This one form is 1 minus sin x dx. How will you find the integration of this form 1 minus sin x? Because we have the formulas like the integration of sin x, cos x, tan x, sec x, cosec x, and integration of cot square x, integration of cosec x, cot x, integration of sec x, cos x, integration of a to the power x, e to the power x, x to the power n, 1 by a and constant. So which particular form is going to fit in this case? This is, you can just manipulate it trigonometrically to get the desired form. If they are not fitting directly into the one form, then how you can do that? So here in this case I find that if I multiply this with 1 minus sin x, it's already there. So if I multiply it with 1 plus sin x, because I know that 1 minus sin square x is cos square x, and 1 minus sin square x can be factorized as 1 minus sin x, 1 plus sin x, and this is cos square x. So I already have 1 minus sin x. If I multiply up and down by 1 plus sin x, I may get something interesting. So 1 plus sin x, then there it becomes 1 minus sin x and 1 plus sin x, and this is dx. And there you see it becomes 1 plus sin x over, this is, I write directly cos square x dx. Now here if I write 1 upon cos square x, separate 1 upon cos square x dx plus sin x upon cos square x dx. Now when you see this form, then you find, oh my god, I got a recognizable pattern, because integrations 1 over cos square x is sec square x dx, and this another one, sin x over cos square x is sec x tan x dx. Now if you find the integration of sec square x, you directly get tan x, plus integration of sec x tan x is just sec x plus c. So this is how you can get. Otherwise, you see, for just looking at this step, you will never assume that you are going to get this form. For that, you need to have the command over the algebraical identities and the trigonometrical identities, and you just need to remember all these different formulas. Same way, suppose if it is 1 plus sin x, then you can multiply with 1 minus sin x, like that, and then there you get minus, there you get minus, there you get minus, and that is the answer with the same thing, only this minus one. Same way when you have the form. So now you can understand the forms. This is 1 plus minus sin x, this form you can manage this way. And if you take 1 over 1 plus minus cos x dx, this form also can be solved the very same way, because 1 minus cos x, 1 minus cos x, and 1 plus cos x multiplied always gives you sin square x, because 1 minus a and 1 plus b is like 1 minus cos square x, and this gives you sin square x. Now I need to clear the screen. I'll take another form. Now I have another form which goes like under root 1 plus sin x dx. So you just saw that in the previous video, when I had 1 plus sin x, I multiplied it with 1 minus sin x up and down. But here in this case, what will happen if I multiply it 1 minus sin x up and down? So there is no down directly, but you can just assume that there is one fraction there, and then you can multiply it 1 up and down by 1 minus sin x, but this will not take you anywhere. Why? Because just in the previous case, you remember 1 plus sin x, on the multiplication this one was able to give you sec square x minus sec x tan x. In the last case, when you had 1 over 1 plus sin x, so if you multiply it with this 1 plus, multiply it with 1 minus, you may get this, either this form in this way, it can be 1 upon, or, but in this case, when it is inside the square root, you will have your form in this particular, not exactly, but these two terms will be there, either up, down, or, but in this case it will be all into the square root. It means you can't do anything with that. So we don't need to apply the same treatment what we meted in the first case, but here we'll think differently, rather rationally, in a pure unique way. How? So you know that those who have dealt with the trigonometrical identities, they know that one can be written as sine square something plus cos square something. So one can be written as sine square x plus cos square x. One can also be written as sine square x by 2 plus cos square x by 2, or sine square whatever plus cos square whatever. Why I'm talking about the x by 2? Because this sine x. So again I take you back to the journey of trigonometry. When you have 1 plus sine 2x, at the place of this one you can write sine square x plus cos square x, and this sine 2x you can write as 2 sine x cos x. So whatever I am solving in these questions, only one which is very versed with the algebraical identities, trigonometrical formulas, trigonometrical ratios, significance and the meaning, only they can comply with my concept. So 1 plus sine 2x is sine square x plus cos square x plus 2 sine x, and this one can be written as sine x plus cos x whole square. Now when I have sine 2x, I can use this idea, but when I have just sine x, I don't have sine 2x. So what I'll do, instead of sine x, I write sine 2 dot x by 2. So sine x can be written as 2 sine x by 2 cos x by 2. So this form will become under root sine x by 2 plus cos x by 2 whole square dx. And this is root is gone because inside the root you have got a perfect square. So this is sine x by 2 plus cos x by 2 dx. Now this is the sum of integration. You find the integration of the sum. So sine x by 2 dx plus integration of cos x by 2 dx. Integration of sine x by 2 is minus sine, integration of sine x is minus cos x. So minus x cos by 2 divided by the differentiation of this constant x by 2, that is half, plus integration of sine x cos x by 2 is sine x by 2 upon very same way half plus c. So this will become minus 2 cos x by 2 plus 2 sine x by 2 plus c. This is how this particular form can be solved. Now I'll clear the screen, I'll take another form. Now I have another form which goes like this: integration of tan inverse under root 1 minus sine x over 1 plus sine x. 1 minus sine x over 1 plus sine x dx. And you know that there is no direct formula for tan inverse right now. You don't have any formulas where you can find the integration of tan inverse something. Then what you can do? But in the trigonometrical identities, along with the ideas of the inverse trigonometric functions, you know that if this given form can be expressed in the terms of tan, because the idea says that tan inverse tan alpha is just alpha if it's defined in this given domain. So if I can possibly transfer or transform this particular form into the expression of the tangent, then I can get rid of this tan inverse. Now how? Now here it is. So first I write 1 minus sine x upon 1 plus sine x. So just in the previous question you saw that 1 minus sine x can be written as sine square x by 2 plus cos square x by 2, that is for 1. And this sine x, if I go into the sub multiple form, so sine 2 theta is 2 sine theta cos theta, and sine x in the sub multiple form will become 2 sine x by 2 cos x by 2, which can be converted as a square plus b square plus 2ab. That one can be written as sine x by 2 plus cos x by 2 whole square. And this one, this is minus, so I'm sorry, this is minus and this should be minus. And you know that the a minus b whole square can be written as b minus a whole square. So first I try to write this 1 minus sin x as cos x by 2 minus sin x by 2. Why I am doing that? Because I have a reason. You'll come to know this little later. So the 1 minus sin x can be written as cos x by 2 minus sin x by 2 whole square over cos x by 2 plus sin x by 2 whole square. The same method, when it is minus, you are having this one. When you have this plus, then this will become plus and this will become plus. So the same reason. Now you see this whole expression inside the root, first it has been converted into the perfect squares. So now you can take a sigh of relief because this root is at least gone. So now if I put the whole thing into this root, then this will also be in the root, and then you find that the square root is gone. Then what I get? That is cos x by 2 minus sin x by 2 upon cos x by 2 plus sin x by 2. Are we close? Well, not yet. Now you know that if I divide this expression by cos x by 2, I am saying because I remember most of the formulas and I know how to apply them. And if you are young learner, then you have to remember all the formulas, because when the formulas are there in your head, then the forms, when you see the forms, then the formulas in your head will suggest that what kind of applications it requires. So now here in this case, I'll try to divide it by cos x by 2. So divide up and down by cos x by 2. So this becomes 1 minus tan x by 2, and this is 1 plus tan x by 2. Now we are very close because we have seen this form and this is tan inverse. Now still one step away because there is a formula called tan a minus b. So the tan a minus b is tan a minus tan b upon 1 plus tan a tan b. But we don't see the tan a. So I can introduce the idea of 1, and that 1 is actually tan pi by 4. So I can write this as 1 minus tan pi by 4, that is 1, tan x by 2. And this is 1 plus tan pi by 4. You can treat tan pi by 4 as 1. So now when you see in this form, then what the form we have? Tan a minus b, that is 1 minus tan a tan b. That also, here I made a mistake. This tan pi by 4, this 1 should be replaced as tan pi by 4. Down one, it is fine. So here we see we have the form tan a minus tan b over 1 plus tan a tan b. So now at the place of this I can write tan pi by 4 minus x by 2. It means this whole thing 1 minus sin x upon 1 plus sin x whole under root can be written as tan pi by 4 minus x by 2. So first let me clear this part of screen. So under root this one can be written as tan this much. So I write here this one directly. That is tan inverse tan pi by 4 minus x by 2 dx. So tan inverse tan is tan inverse tan alpha is alpha. So this is just pi by 4 minus x by 2 dx and integration. So first you find the integration of this one, then we have to write as integration of pi by 4 dx minus integration of x by 2 dx. So pi by 4 is constant, just take it outside. Then it is just integration of 1 dx, that is x, minus take half outside. The integration of x is x square over 2 plus c is constant of integration. So this is pi x over 4 minus x square by 4 plus c. So this is the solution of this particular form. So here you see that if you want to solve the problems of integration smoothly, then the many formulas should be at the tip of your tongue. Then only you can solve them easily. Now I take one more form, and there we'll learn how you can integrate this form. Now we have a form of how to find the integration of sine square x dx, or integration of cos square x dx, or integration of sine to the power 4 dx, or integration of sine to the power 3x dx, or cos to the power 3x dx, like this. So because we have the formula says that what the formulas we have the formulas for integration of sine x. The formula says that integration of sine x dx is minus cos x plus c, and integration of cos x dx as sine x plus c. But we don't have any formula for sine square x and cos square x. How can you do that? We will use the idea of trigonometry, because in trigonometry you know that cos 2x equals 2 cos square x minus 1, or 1 minus 2 sine square x, and the main formula goes like cos 2x is cos square x minus sine square x, and this formula, it has come from this formula that cos a plus b is cos a cos b minus sine a sine b, and if you make a and b both as x, so this becomes cos 2x is cos square x minus sine square x, and you know that the cos square x can be written as 1 minus sine square x. So if at the place of this, if you write 1 minus sine square x minus sine square x, so you'll get 1 minus 2 sine square x, and if at the place of this sine square x, if you write 1 minus cos square x, you'll get this 2 cos square x minus 1. So whenever you see that this is sine square x, you can use it as this relation. And then what do you find? That the sine square x is, take this one on this side, this one on this side, so it's 1 minus cos 2x over 2, and then if you write cos square x as 1 plus cos 2x over 2. So whenever you have to integrate sine square x dx, you don't integrate sine square x directly, but at the place of this you write this one. So I go for this form, so it takes 1 minus cos 2x over 2 dx, that is integration of half and 1 dx minus half and integration of cos 2x dx. That is half integration of 1 dx is x minus integration of cos 2x is sine 2x over 2 and half plus c. So this becomes 1 by 2x minus 1 by 4 sine 2x plus c. So for sine square x, integration of sine square x dx, you get 1 by 2 x, this is like x by 2, half x minus 1 by 4 sine 2x plus c. Same way, when you have to find integration of cos square x, you can use this relation to find the integration of this cos square x. In the very same way you can find, because it's getting 1 plus cos 2x over 2, so only this whole thing remains same, only this negative term will become positive. Now what about this sine cube x? For sine cube x, again you need to know the formula which says that sine 3x can be written as, what is the formula of sine 3x? Sine 3x is 3 sine x minus 4 sine cube x. Now take this 4 sine cube x on this side, so you'll get sine cube x for this is 3 sine x minus sine 3x. So directly you cut this 4 from here, put it there. So these two are same. You don't have to integrate sine cube x directly, you just integrate these two. So if this is equal to this, so integration of sine cube dx is nothing but the integration of dx. Now this is 3 by 4, integration of sine x is minus cos x, and this is 3 by 4, integration of sine 3x is again minus become plus, and that is cos 3x over 3, 3 cancel, so this is 1 by 4 plus c. This is how you can find the integration of this form also. And for sine to the power 4x, again you have to just square these two, then you get 1 minus cos square 2x, and then I think that we should discuss in the next video, because this is already complicated and this video has already become unnecessarily 20 minutes long. Thank you very much, and in the next video we'll deal with how to find the integration of sine to the power 4x or beyond.